Hey everyone, Nitesh this side. Hope you're doing well. So let's start with the question. So the question is count all valid pickups and deliver option. Okay, so you have given n orders. Each order consists in pickup and delivery service. Okay, so what you have to do, you have to count all valid pickup delivery possible sequence such that deliver is always after the pickup. So like always, your pickup will be first entry, then after that your deliver will be the second entry. Okay. And since the answer may too large, so you have to return it modulo 10 to the power 9 plus 7. Okay, so let's see with an example. Okay, so let's take this example. So Rn is equal to 1. So in the question, it's already mentioned like pickup will be first and then will be deliver. Okay, so as you can see, we have only one order. So this will be my first pickup and this will be my the deliver for this. If I have n equal to 2, then I have other pickups also. So for this case, I only getting one output, so that's why the output is 1. Okay, so let's see for n equal to 2. Okay, so for n equal to 2, I have two orders basically. Two orders basically means two pickups and two delivers. So I can arrange them in any order, but in the question it's always like the current pickup will always first, then deliver. Okay, so what we will do, we can arrange them like p1, p2, then deliver 1 and deliver 2. Okay, now it can be like this: p1, p2, your delivery 2 first and delivery 1. Okay, now you can arrange this like p1, p2 will be first, then p1, and then d1, d2. Okay, you can also now arrange it p2, p1, your d2 will come and your d1. Okay, similarly you can arrange them like this: p1 will become, then d1, then p2, then d2, then you can say p2, d2, then your p1, d1. Like like the pickup can be in any order, but the current pickup and the current delivery will always come next. Okay, so as you can see, we are getting 1, 2, 3, 4, 5, 6. So that's why the output is 6. Okay, so I hope you got the question. Like we need to first set the pickup, then the corresponding deliver will come back. You may also can see like uh, P1, then you can say D2, and you can say P2, then D1. This can't be a possible combination because the current pickup will be come after the deliver. So that's why this is not a valid option. Okay, so these are the 6 valid options. Okay, so let's see how we can approach this question. Okay, so let's approach this question. So let's take again the n equal to 2. So for the n equal to 2, we have 4 possible options: 1, 2, 1, 2, 3, and 4. Okay, we can arrange them in any order. Like we have the option of 2 P's and 2 deliver, but the P will always come first. Okay, so if you want to calculate the permutation for the pickup, like if it is P1, P2, you can arrange them like P2, P1. Okay, so as you can see, this is just a permutation. Okay, let's say n equal to 3. So then you will arrange P1, P2, P3. Similarly, you will arrange it P1, P3, P2. Then you can arrange P1. Okay, so as you can see, for n equal to 3, we have this 6 combination. Okay, and if you know the permutation formula, it's like a n factorial. Okay, so for the pickup, you can arrange them in a n factorial. Now let's calculate for the delivery. Okay, so for the pickup, you got your time complexity, it is n factorial. Like you can solve this n factorial. Now let's see how we can deliver also. Okay, so for the delivery, let's do like this. P1, we have, let's say n order. P2, let's say this is Pn. Okay, now your delivery n will always come after Pn. Okay, so for the delivery n, you only have one option, like you can only arrange at here. Okay, so this will be your only one option. You can arrange them here. Okay, let's arrange Pn minus 1. Okay, so what we will do, let's write down P1, P2, we have Pn minus 1, and let's write Pn and let's write down Dn. Now we need to arrange Dn minus 1. So Dn minus 1 will always come after Pn minus 1. Okay, so what are the possible option we have to arrange it? We can uh, take it here. Okay, similarly we can take it here also, like Dn minus 1, we can take it here also, and here also. So we have three options. Okay, now let's see for n minus 2. So this is P1, P2. It will generate a pattern. Okay, I will update you. Pn minus 1, Pn, Dn, Dn minus 1. Now let's arrange Dn minus 2. Okay, so Dn minus 2 will always come after Pn minus 2. So we have one option, we have second, we have third, this is fourth, and this is fifth. So we have five possible options for this. Let's see for Dn minus 3 also. Okay, P1, P2, this will be Pn minus 3, Pn minus 2, Pn minus 1, Pn, Dn, Dn minus 1, Dn minus 2. Okay, so we can arrange Dn minus 3 here also. We can here also, at this position also, at this also, at this, at this, and at this. So if you count that, 1, 2, 3, 4, 5, 6, 7. Okay, so we have calculated for Pn minus 3. Let's say we want to calculate for P1. Okay, so if you arrange, like we need to arrange D1. Okay, so if you can see this pattern 1, 3, 5, 7. Okay, if you write down it like 1, 3, 5, 7, and you want to calculate the last term, this is sort of a AP. Okay, so let's calculate this last term. Okay, so let's calculate this an. So if you know the formula for this, a plus n minus 1 d, we can take a as 1 and plus n minus 1, and our d is the common difference. So as you can see, 3 minus 1 is 2, 5 minus 3 is 2. So this will be 2. So equal to 1 plus 2n minus 2. So this will be 2n minus 1. Okay, so this will be our 2n minus 1. Okay. So for the delivery, if you can see, like this will be 1, 3, 5, 7, and this will be 2 into n minus 1. So this is we are getting for delivery, and for pickup we already know, like this will be n factorial. So if we calculate overall, like how we will calculate, so it will be n factorial into 1 into 3 into 5 into 7 into 2 into minus 1. So by this we can easily get our solution. Okay, so let's try with some example. Let's see for n equal to 2. Okay, so if you can see, we can also modify this. So this will be, let's calculate for this n equal to 2. So for n equal to 2, what you need to calculate, 2 factorial into, so the maximum value for this equal to 2 into, we will do 2 into 2 minus 1, this will be equal to 3. So you will do 1 into 3 only. Okay, so if we solve this, 2 factorial, this will be 2 only, and this will be 3 equal to 6. Okay, let's take one more example. Let's take n equal to 3. Okay, we can also update it, like n factorial is just like 1 into 2 into 3 into n factorial. So if you want to calculate this current, like we will do on a loop basis. So what we will do, we will loop from for I to n. Okay, for n factorial we just multiply it with the current I. For this, what we will do, we will take it like 2 into I minus 1. Okay, so let's say you want to calculate this. So at this point your I is equal to 2. So you will do 2 into 2 minus 1. So this will give you 3. Okay, so let's do like a loop for I1 to n. Okay, so what we will do, we will start from here. Okay, we will calculate this. So for the n, so we will start from 1. Okay, so our result will store 1 into, and you will calculate this 2 into I minus 1. So your current I is 1. Okay, so you will do 2 into 1 minus 1. So this will be 1. You will do 1. So your result is 1. Now you will update your I into 1. Okay, so you will calculate only your result by result into current I. So your current I is 2, it's 1. Okay, this time it's 2, so this will be 2. You will calculate this 2 into I minus 1, so this will be 2 into 2 minus 1, so this 3. So you'll do 1 into 2 into 3 equal to 6. Okay, so similarly you will do till when your I equal to 3, you will do res equal to 6 into 3 into this 2 into I minus 1 is for your delivery, so 2 into 3 minus 1, 2 into 3 is 6, minus 1 is 5, so this will be 5. Okay, so 6 3 is 18 and 18 into 5 into 90. So this is the final output that you are getting for n equal to 3. Hope it will be clear to you. So let's write the code for this. Okay, and like as you can see, the calculation will be large, so we need to do mode also with our result also. Okay, so let's write the code for this. So first of all, let's take a mode variable equal to math dot power 10 to the power 9. Like in the question it's mentioned 10 to the power 9 plus 7. Okay, let's convert this into long. Okay, now let's take a result variable which will be start from 1. Okay, so we'll loop from 1 to equal to n. Our first step is just do res into equal to I. So this is for permutation, sorry, this is for pickup. After this we will mode the number. Okay, and after this we need to do for our, you can say for delivery 2 into I minus 1, and again we'll do mode operation. I think we have done with all the calculation. After that we just return the result. Okay, and we need to cast it into int. Okay, let's run the code. As you can see, our code is accepted. Let's try for 3 also. So as you can see, we are getting the output as 90. Okay, let's submit it. So our code is submitted. So the overall time complexity for this is big of n, and the space we are just doing a constant space. So that's it for this video. Thank you for watching my video.